Hi there. So, what I want to go over with you is the resistance of a conductor based on the circular mill area. Resistance based on the circular mill area uses the formula R equals K times L divided by cross-sectional area. The R stands for the resistance in ohms. The L is the length in feet. K is a constant. We've seen Ks before. We don't use C because of circumference in other places where C is used. The two types of wire or conductors that we most commonly use are copper and aluminum. The constant for copper is 12.9 and the constant for aluminum is 21.2. CSA and CMA basically mean the same thing. CSA is cross-sectional area. CMA is circular mill area, and those two are often interchanged. So the cross-sectional area is actually measured in circular mills, and you can find that cross-sectional area in Table 8 of the NEC Code Book. Should you continue on in college with electrical training, you will learn how to calculate the CMA from the diameter, and you will learn how to calculate the constant per mil foot. We can just use the givens above and the NEC code book to look up our circular mill area. Hopefully you remember there are four factors that affect the resistance of a conductor. The length of the wire itself. If it's short, less resistance than if it's long. So if I have a piece of copper wire of a certain resistance and I double the length, I double the resistance. The cross-sectional area. The smaller the cross-sectional area, the more resistance. The larger the cross-sectional area, the less resistance. So if we have two pieces of conductor of the exact same material and the same length, and one has a resistance of 2 ohms, and then we have another one with twice the diameter, it's twice as big, we will half the resistance. And then the temperature. Basically, as the temperature increases, so does the resistance. And lastly, the type of material. Iron has more electrical resistance than a geometrically similar copper conductor. We know that the three best conductors of all time are silver, copper, and aluminum in that order. We do not use silver just because of how much it costs to use silver. So copper and aluminum are the two most commonly used. You will see here a section of screenshots of Table 8 conductor properties. This is found in Chapter 9 of the NEC Code Book. And on this Chapter 9, Table 8 has conductor properties. And there's a couple different things on here, but what we're going to concentrate on right now is the AWG and the area in circular mills. There are other resistance here of copper and aluminum based on ohm per kilo feet is what we would use, this here one. But we're going to use the two constants that we have. So how do we use this table? Let's take a look at number 18, number 12, and number 8. If I go to number 18, the cross-sectional area is 1,620 circular mils. If I go to number 12, go over to the circular mils and read the number. It's 6,530 circular mils. If I go to number 8, it's 16,510. So notice the further down you go, the smaller the AWG, the larger the cross-sectional area. What if I had to determine what size conductor I needed if I knew that I needed a cross-sectional area of 32,230 circular mils? So I'm going to see if I can find 32,230 circular mils. So I'm looking for 32. Wow. 20, 16, 26. Way down here. I have to fix, there's an error on here. So when I get down here, I'm looking for 32,000. If you look at 6, it's 26,000. If I look at 4, it's 41,000. I would have to choose number 4. This should say 4, not 14. So I will correct the PowerPoint. Actually, let me just do it right now. Okay, so we have to go all the way to number 4. It is the smallest one that will have 32,200 circular mils. If I go to 6, it's too small. What if I needed to determine what size conductor has a cross-sectional area of 25,850? 25,850. So I have to keep looking. 25,000. Well, we have 26. So we go from 16,000 to 26,000. 16,000 is too small. 26,000 is a little bit bigger than 25,000. So I can choose number 6. If you look at number 14, which is a common one that you've been using upstairs in the lab, it says 4,110. So this is very common household wire. It's why it's highlighted here for you. I have put a portion of Table 8 in the slideshow for you a few times. So when you're doing your work, if you don't have your NEC code book, which it would be better to have your code book, you can look on here for the table. Excuse me. So the two columns we're going to worry about is AWG and circular mils. So here's a sample question for you. A 10-foot piece of solid copper wire has a resistance of 38 thousandths of an ohm. Use the wire gauge table to calculate the size of the wire. First thing I'm going to do is bring up this formula. I'm going to write this formula down in my notebook, and then I'm going to fill in the pieces that I know. 10 foot. So where the length is, I'm going to put in 10. Has a resistance, I see the word copper. Copper. Where the K is, I'm going to substitute 12.9. And a resistance of 0.038. So where the resistance is, I'm going to fill that in. Sorry. So here are my substitutions. The next thing to do are the calculations. Well, this is easy. 12.9 times 10, I just move this over and I get 129. So I'll have 129 over the cross-sectional area. So that's what you'll see come up next. This times this is 129. And then to get the cross-sectional area off, I multiply both sides by the CSA. So the resistance times CSA equals 129. Now to get the cross-sectional area by itself, divide this side and this side by 0.38. So I'm going to divide the 129 by 0.038, and I will get 3394.7. The next step is, once you determine the cross-sectional area in circular mills, go look at Table 8. You must choose the smallest wire size that meets at least this cross-sectional area. So in this case, number 14 copper conductor is required. How did I get that? I'm looking for a cross-sectional area of at least 3,394. So 3,394. Too small, a little bit bigger, gives me size 14. That's where the size 14 comes from. Here's a second example for you. Determine the resistance of 250 feet of number 10 aluminum conductor. First thing I'm going to do is write this formula. A resistance of 250 feet. So where the L is, I'm going to write 250. Of a aluminum conductor size 10. Well, aluminum 21.2. So this is going to be 21.2 times 250. And now I need the cross-sectional area of size 10 aluminum. I go to Table 8 and I read it. It will say 10,380. So if I go back here, remember we're looking for number 10. Go to number 10, 10,380. So that brings me to this value. Now I can start substituting. I know the K, I know the L, I know the cross-sectional area. 21.2 times 250 for the length divided by 10,380. Multiply 21.2 times 250 and I will end up with 5,300 divided by 10,380 and I will end up with a resistance of 0.511 ohms. So that will be the amount of resistance in 250 feet of number 10 aluminum wire. I have put this chart in the PowerPoint several times. It is better should you use your code book. So you are going to do a Google form on some of this work. Some of it's simply reading tables and some of it is doing some calculations. If you do not have your NEC code book, use the screenshots of Table 8 contained in this slideshow and the formula in this slideshow to answer the questions in the Google form. Please try to use your code book. I hope you find this helpful. Bye.